G'day guys. Let's start now. Let's hope this stream has started successfully. Now, with regards to the expanding universe, and what's more, it's accelerating. I mean, does that make any sense? What is it expanding into? I mean, is it converting something to nothing to do that? I mean, think about it. If we treated the universe as something, right, the only thing that's left is nothing. Because the universe, encapsulates everything. This means we've got something that is a one unit, and everything that is something is part of it. Therefore, everything that we look at, everything that we treat in physics, right, we are actually working with, or looking at a percentage of it. So this means we need then to understand how something exists and how does it interact with the rest of the universe. I mean, if anything happens, right, the rest of the universe has to reciprocate. Like, just say I look at a tree, right? That is a percentage of the universe. Now, as it crumbles away, right, and gets changed into something else, right, the rest of the universe, right, is changing also with it. So what I'm trying to point out is, if we divided the universe into two portions, we'd have half, each a half, let's say. Now, if one half changed, its percentage would change, as with the other percentage. Therefore, the simplest way I can think of it is it's a waveform, right? Now, if it's a waveform, right, that means everything's constantly changing, and there's two phases. There's one that's peaking, and then there's one that's troughing or going, it's doing the opposite. It's keeping the single one whole, so it doesn't change. That's the constant. The universe is everything and anything, right? So therefore, everything that we do. Let's go this way because sorry about that. I'm in a game at the moment. Just so just so we've got a moving scenario. What we're more interested in is we need to think about what the actual universe is expanding into, right? And if it's expanding into something, I mean, it can't dissolve into nothing. So this is what my proposal is, or this is what I think is happening. It's not expanding at all. And if we look at our galaxy, right, it seems that the galaxies are actually being, like they're being squeezed and compressed. Whilst the distances between galaxies seems to be, is what is actually expanding. So if we look at that, right, we need to also then consider that, well, the distances between any mass, I mean, could that also be a mass? Or is it nothing? Is it empty space? So what is empty space? If it's dimensionless, right, with no dimensions, that means any mass will have to touch or be in contact with another mass. So in my way of thinking, right, I've got it that, well, obviously then there's no such thing as nothing. I mean, here we are something, right? We're acknowledging the rest of the universe. And, excuse my throat, I've got a bit of a condition where I've got gastro, and the gastro, it really burns my throat and my voice box because it keeps coming up and whatnot. Herniahitis, I believe it was called. Anyway, getting back to, mass has to be, every bit of mass has to be in contact with the other mass. But see, it can't be. That means no mass is solid. That's what I'm getting at. So what is it that makes it so that the mass isn't solid? And I'm thinking, well, what happens if we, treat it as mass energy? Because that's what physics. That in physics, that's what we treat everything as, mass energy. It's either a mass, right, or it's energy. But I think that's wrong. I think it's a ratio of mass energy. And if we refer to, let's say, general relativity or special relativity, right, we can sort of correlate those two. And what happens is, if we have a mass, right, it has to be reasonably solid, and therefore it has to stop changes, or it has to slow changes the more we go to the center of whatever the mass it is. Now, if we think of like when we go, say, out on a flight to the moon, as we leave the Earth, we've discovered that time actually speeds up within the spacecraft, or within the vessel, the further we go away from mass. And that makes sense, because a mass, right, it is more solid, more of the energy has been stored. Changes take a longer time because the energy that presents changes, it's been stored. So how does this storage mechanism work? I mean, the only way I can sort of describe that is maybe if we imagine a grid, and we then look at the central grid area and imagine if that was to shrink, and what kind of shape would we get with the rest of the grid? It'll be more or less like it, as if they're all pointing, and there's all these triangles, and the further apart or further away from the central dot, the bigger the triangle. And I don't know, it's not exactly a triangle. It starts beginning to look like a chopped off pyramid. Think of a pyramid as a section. Now I'm talking three-dimensionally here. Or if we looked at a two-dimensional picture, we draw the pyramid and then we'd rub out the top part. Right? Now if we look at general relativity, right, all the depictions that we get, what's it look like? What do they depict? They depict a mass, as such as a planet or a moon, and it's got these grids that sort of intersect to the center of that mass. That's a two-dimensional picture. But see, when we look at the three-dimensional pictures, they show a mass on a mattress or a rubber sort of sheet, which is wrong, I think. It doesn't make sense. I want you to think about that, all right? And if we look at it, it actually goes that the closer we get to the center of the mass in 3 dimensions, the more solid it has to be. The more the energy is being converted to a mass. So if we just say we were on top of that mass, like a planet, we would actually then feel the actual inward momentum towards the mass. We'd be part of it too. Right? And we would feel it. And that's the gravity. So therefore, the storage mechanism of mass is gravity. That's what I think it is. I want to hear your thoughts. I want to hear you or see your comments down below. Tell me what you think. Tell me if I'm on the right track here. I'm going to make another live feed. I'll probably make one every day. Thank you, darling. That's the Mrs. Gomez. Just going to give me some snackies. Yeah, I want you to subscribe. Tell me what you think, and join in these live feeds. I'm going to do these live feeds more and more as we begin to interact through this live chat. I want to get your theories, your questions. I want to see if we can get some kind of truth about the actual universe. And I really honestly think each and every galaxy, right, via how the sun works, is shrinking, or it's like if we go to the center of the galaxy, what do we got? We just only recently discovered it's a black hole. There's a black hole in the center of the galaxy. No light escapes, which suggests one thing. The speed of light can be actually violated. But relative to what? See, general relativity and special relativity are so entwined with each other that I really think that if we go closer to the actual core of the galaxy, time will actually take longer, or changes, should I say, will take longer. Therefore, we will slow down, right, relative to observers further out or further away from the core of the galaxy. What the hell's this? First time I even noticed that. Go around with my eyes shut. Anyway, getting back. Getting back to the galaxy, the center of the galaxy, and how I think each and every galaxy is the compression point, and how, well, I don't like the word suck. You know why I don't like the word suck? Because a force can't be attractive. A force is always repulsive. Now, I know people say, well, for each and every action there's a, opposite reaction. Well, I reckon that's a bit of bullshit there. Excuse my language if you're not used to language, but if you're a realist and, you know very well everyone uses colourful language. Let's just overlook that. See, I know for a fact, right, and I understand how actual mass is possible. And earlier on, I mentioned that greeting, right? And I mentioned how, well, try and imagine how, what would happen if we sort of pinched the middle sort of grid. I could kill those, but I don't want to kill them. They're all glowing and I'm going to have to deal with radiation. Anyway, getting back to the where was I? Oh, jeez, I got completely distracted by those off. So, yeah, about the pinching of the actual a space and storage of a space. Now, can you imagine, right, if we had two gases, say two hydrogens, right, what would happen if we actually compressed them together and made out of the two spaces one space? It would have to be solid, wouldn't it? Well, not solid, but it would have to be dense. It would have to be denser than its surrounding area. Changes within that space, therefore, would be slower. It would take longer because it's, some of the energy is being stored. And therefore, within that area, time will actually be slower. So what I'm talking about here now is, how did hydrogen first come about? Well, near vacuum. Now, a lot of people treat near vacuum, well, space, outer space that I'm talking about now, they used to treat it as empty space, but I never did. I always saw it as a mass, but a highly energetic mass. More energetic than anything else. I reckon, the universe is made up of this highly energetic mass, which I call near vacuum. And the reason why I call it near vacuum is because it is not empty. It's something. Hello, Yowie. Oh, it detected me. I better run out and better sneak away from it. Anyway, it's not empty because we know light or electromagnetic waves ripples through, right, the space. And if we look up, we see the stars. Those stars are the suns, right? And or the it's like our sun, fusion. And if we look at fusion, what does it do? It gets two dense areas of space, or two dense masses, which is compressed near vacuum, and makes it into one space, two spaces, or maybe even more spaces, all made into one space. But see, what happens is, what takes over that space that's just been lost? Does the rest of the universe get more energetic? I mean, if we think about that, right, and we're actually in a space, the galaxy is a mass where it's got areas where time is being slowed, relative to space, right? And what's in space? It's the electromagnetic waves. So what happens if they actually seem to be actually quicker? That would have to be, I don't know, what do you think? I'm going to leave it at that. Because I'm hoping, as a physicist, you've just stumbled upon this video to give you, and you're interested to see what other people think. I'm not a physicist by all means, right? But I do know a lot about our universe. I've always pursued information, and I've always pursued information where I can collaborate that information and make it fit, like a jigsaw puzzle, with other information. And I've dropped a lot of crap. I hear so much crap, and this is what I'm doing right now. I honestly think the universe can't be expanding. It's not. And I honestly think the Big Bang, right, is not actually the starting point, the point of creation, because that would be just a cop-out. You can't get something from nothing. I reckon the universe has always existed. It's never ever been nothing. It never was created. It just is. Anyway, I'm going to leave it at that. I hope that I get a few more people in my next live stream, which will be a while. I like to think about things and mull things over. I'll be going over this video to see how I can clarify my thoughts, because I'm new to trying to express myself verbally, and I also want some feedback on what I should be sort of contemplating or thinking about when it comes to relativity, general relativity, special relativity, and more importantly, how and why they are at a disparity to quantum theory. Yeah, that's right. I've delved a bit into it, right? And I know I've got an inkling where quantum theory is actually why quantum theory is missing a lot of data. But it's going to be hard to sort of eke that out unless I get some help from some really top guys like you watching this. So yeah, once again, I'd like to thank you for watching, and I really seriously hope that you will leave a message on the chat, and I will answer back, and we will probably then resume live on our live feed to see if we can eke it out with even more people. I need a big audience. I mean, we need to have some kind of I don't want people fighting. I mean, I go to so many physics forums and everyone argues because they've got this set mind. What I want to do is I want you to actually have a say and be prepared to actually be, debunked. Like I want to be debunked. So this is a forum, or this is going to be a media where you can test out what you think and what I think. I want you to debunk me. Alright? So hit that subscribe button, hit that notification button, Because when I go live next, I want to hear from you. Maybe a couple of days, or maybe a week, maybe even a month. But as soon as I get enough people, right, that are addressing this expansion problem, and they've got some kind of comment that is warranted that we all talk about it, then yeah. We don't want to argue, all right? We just want to be, to the point. Thanks for watching, guys. And I'll catch you in the next live stream, I hope. Or in the chat down below. Bye for now.